In this video, I'll show you how to solve the exercise meltdown mitigation. So let's jump to the instructions and see what task 1 says. I'll just remove this. The first thing a control system has to do is check if the reactor is balanced in criticality. A reactor is said to be balanced in criticality if it satisfies the following conditions. And there's a number of conditions. Implement a function that takes temperature measured in Kelvin, neutrons emitted as parameters, and returns true if the criticality conditions are met, false if not. So this is it just needs to return like a Boolean value, I think, of like true or false. So you can just start with return, then brackets, then temperature is less than 800K, and number of neutrons emitted is greater than 500, and the product of temperature and neutrons emitted is less than 500,000. Let's just check if this works. Yep. So that's task 1. Task 2. Determine the power outage. I'll just remove these comments again. Once the reactor has started producing power, its efficiency needs to be determined. Efficiency can be grouped into 4 bands: green, orange, red, black. The percentage value can be calculated as generated power divided by theoretical max power times 100. So let's create a variable called percentage value is generated power divided by theoretical max power times 100. This one is not defined yet, so we'll define this variable as well. Generated power is voltage times current. Implement the function, 3 parameters. This function should return. It should return something. It should return the efficiency band of the reactor. Efficiency band. Green, orange, red, or black. So now we need to create an if statement. If efficiency of 80% or more, so if percentage value is more than or equal to 80%, then the status code, the efficiency band, let's say the efficiency band And let's create a string called green. Then elif percentage value is less than 80%, less than 80. But at least 60%. And percentage value is bigger than or equal to 60%. Efficiency band is orange. LF percentage value, efficiency band, efficiency below 60%, so less than 60, but still more than 30%, and percentage value is bigger than or equal to 30% or more, 30%, and then the efficiency band is red, and less than 30% efficient, so we have from 100 to 30, and now we can just use an else statement. So in other cases, so if it's less than 30%, then the efficiency band is black. Return efficiency band. Let's try and see if this works. Yep. And then we have task number 3. Fail-safe mechanism. Just remove this. Final task involves creating a fail-safe method, and then a bunch of if statements. It outputs a status code for the reactor. Return a status code. If temperature times neutrons produced per second is smaller than 90% of thresholds, so 0.9 times the threshold. Status code is low if LF temp. Okay, let's just put this thing into a variable. So this is temperature times neutrons produced per second. So we can just call this I don't know. Temp neut is temperature times neutrons per second, and then we can change this to use that variable, and the elif statement temp. Okay, is within 10% of the threshold, so either 0 to 10% less than the threshold, or 0 to 10% greater than the threshold, so it's 0.9. Temp newt is 0.9 times the threshold is bigger than or equal to the threshold, and it is smaller than or equal to, so this variable is smaller than or equal to 1.1, so 10% more than the threshold times the threshold. And then the status code should be normal. The next if statement, if is not in the above stated ranges, the reactor is going into meltdown and needs to have the code danger, so we can just use the else statement here. Else status code is danger. Return status code. Let's run the test. Done. That's it.